Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to 2n. Substitute 1 for n. Simplify 2 times 1. You find that a1 is equal to 2. Substitute 2 for n. Simplify 2 times 2. You find that a2 is equal to 4. Substitute 3 in for n. Simplify 2 times 3. You find that a3 is equal to 6. Substitute 4 in for n. Simplify 2 times 4. You find that a4 is equal to 8. Substitute 5 in for n. Simplify 2 times 5. You find that a5 equals 10. The first 5 terms of the sequence are 2, 4, 6, 8, and 10. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to 1/4 quantity to the nth. Substitute 1 in for n. Simplify 1/4 to the first. You find that a sub 1 is equal to 1/4. Substitute 2 in for n. Simplify 1/4 squared. You find that a sub 2 is equal to 1/16. Substitute 3 in for n. Simplify 1/4 cubed. You find that a sub 3 is equal to 1/64. Substitute 4 in for n. Simplify 1/4 to the fourth. You find that a sub 4 is equal to 1 divided by 256. Substitute 5 in for n. Simplify 1/4 to the fifth. You find that a sub 5 is equal to 1 divided by 1024. The first 5 terms of the sequence are 1/4, 1/16, 1/64, 1 divided by 256, and 1 divided by 1024. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to 5n minus 2. Substitute 1 in for n. Simplify 5 times 1. Simplify 5 minus 2. You find that a sub 1 is equal to 3. Substitute 2 in for n. Simplify 5 times 2. Simplify 10 minus 2. You find that a sub 2 is equal to 8. Substitute 3 in for n. Simplify 5 times 3. Simplify 15 minus 2. You find that a sub 3 is equal to 13. Substitute 4 in for n. Simplify 5 times 4. Simplify 20 minus 2. You find that a sub 4 is equal to 18. Substitute 5 in for n. Simplify 5 times 5. Simplify 25 minus 2. You find that a sub 5 is equal to 23. The first 5 terms of the sequence are 3, 8, 13, 18, and 23. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to 4 divided by n plus 3. Substitute 1 in for n. Simplify 1 plus 3. Simplify 4 divided by 4. You find that a sub 1 is equal to 1. Substitute 2 in for n. Simplify 2 plus 3. You find that a sub 2 is equal to 4/5. Substitute 3 in for n. Simplify 3 plus 3. Simplify 4 divided by 6. You find that a sub 3 is equal to 2/3. Substitute 4 in for n. Simplify 4 plus 3. You find that a sub 4 is equal to 4/7. Substitute 5 in for n. Simplify 5 plus 3. Simplify 4 divided by 8. You find that a sub 5 is equal to 1/2. The first 5 terms of the sequence are 1, 4/5, 2/3, 4/7, and 1/2. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to 3n divided by 5n minus 1. Substitute 1 in for n. Simplify 3 times 1 and 5 times 1. Simplify 5 minus 1. You find that a sub 1 is equal to 3/4. Substitute 2 in for n. Simplify 3 times 2 and 5 times 2. Simplify 10 minus 1. Simplify 6 divided by 9. You find that a sub 2 is equal to 2/3. Substitute 3 in for n. Simplify 3 times 3 and 5 times 3. Simplify 15 minus 1. You find that a sub 3 is equal to 9 divided by 14. Substitute 4 in for n. Simplify 3 times 4 and 5 times 4. Simplify 20 minus 1. You find that a sub 4 is equal to 12 divided by 19. Substitute 5 in for n. Simplify 3 times 5 and 5 times 5. Simplify 25 minus 1. Simplify 15 divided by 24. You find that a sub 5 is equal to 5/8. The first 5 terms of the sequence are 3/4, 2/3, 9/14, 12/19, and 5/8. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to -1 to the nth times 2n. Substitute 1 in for n. Simplify -1 to the first and 2 times 1. You find that a sub 1 is equal to -2. Substitute 2 in for n. Simplify -1 squared and 2 times 2. You find that a sub 2 is equal to 4. Substitute 3 in for n. Simplify -1 cubed and 2 times 3. You find that a sub 3 is equal to -6. Substitute 4 in for n. Simplify -1 to the 4th and 2 times 4. You find that a sub 4 is equal to 8. Substitute 5 in for n. Simplify -1 to the 5th and 2 times 5. You find a sub 5 is equal to -10. The first 5 terms of the sequence are -2, 4, -6, 8, and -10. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to -1/2 quantity squared to the nth plus 1. Substitute 1 in for n. Simplify 1 plus 1. Simplify -1/2 squared. You find that a sub 1 is equal to 1/4. Substitute 2 in for n. Simplify 2 plus 1. Simplify negative 1/2 cubed. You find that a sub 2 is equal to negative 1/8. Substitute 3 in for n. Simplify 3 plus 1. Simplify negative 1/2 to the 4th. You find that a sub 3 is equal to 1/16. Substitute 4 in for n. Simplify 4 plus 1. Simplify negative 1/2 to the 5th. You find that a sub 4 is equal to negative 1/32. Substitute 5 in for n. Simplify 5 plus 1. Simplify negative 1/2 to the 6th. You find that a sub 5 is equal to 1/64. The first 5 terms of the sequence are 1/4, negative 1/8, 1/16, negative 1/32, and 1/64. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to negative 1 to the nth divided by n squared. Substitute 1 in for n. Simplify negative 1 to the first and 1 squared. Simplify negative 1 divided by 1. You find that a sub 1 is equal to negative 1. Substitute 2 in for n. Simplify negative 1 squared and 2 squared. You find that a sub 2 is equal to 1/4. Substitute 3 in for n. Simplify negative 1 cubed and 3 squared. Simplify negative 1 divided by 9. You find that a sub 3 is equal to negative 1/9. Substitute 4 in for n. Simplify negative 1 to the 4th and 4 squared. You find that a sub 4 is equal to 1/16. Substitute 5 in for n. Simplify negative 1 to the 5th and 5 squared. Simplify negative 1 divided by 25. You find that a sub 5 is equal to negative 1/25. The first 5 terms of the sequence are negative 1, 1/4, negative 1/9, 1/16, and negative 1/25. Write the product represented by the factorial, then evaluate the product. 6 factorial. Write 6 factorial as 1 times 2 times 3 times 4 times 5 times 6. Use a calculator to simplify 1 times 2 times 3 times 4 times 5 times 6. You find that 6 factorial is equal to 720. Write the product represented by the factorial, then evaluate the product. 9 factorial. Rewrite 9 factorial as 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. Simplify 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 by using a calculator. You find that 9 factorial is equal to 362,880. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to n factorial divided by n. Substitute 1 in for n. Simplify 1 factorial. Simplify 1 divided by 1. You find that a sub 1 is equal to 1. Substitute 2 in for n. Simplify 2 factorial. Simplify 2 divided by 2. You find that a sub 2 is equal to 1. Substitute 3 in for n. Simplify 3 factorial. Simplify 6 divided by 3. You find that a sub 3 is equal to 2. Substitute 4 in for n. Simplify 4 factorial. Simplify 24 divided by 4. You find that a sub 4 is equal to 6. Substitute 5 in for n. Simplify 5 factorial. Simplify 120 divided by 5. You find that a sub 5 equals 24. The first 5 terms of the sequence are 1, 1, 2, 6, and 24. Write the first 5 terms of the sequence with the given nth term. Assume that n begins with 1. A sub n is equal to n plus 1 factorial divided by n factorial. Substitute 1 in for n. Simplify 1 plus 1. Factor 2 factorial into 2 times 1 factorial. Simplify 2 times 1 factorial divided by 1 factorial. You find that a sub 1 is equal to 2. Substitute 2 in for n. Simplify 2 plus 1. Factor 3 factorial into 3 times 2 factorial. Simplify 3 times 2 factorial divided by 2 factorial. You find that a sub 2 is equal to 3. Substitute 3 in for n. Simplify 3 plus 1. Factor 4 factorial into 4 times 3 factorial. Simplify 4 times 3 factorial divided by 3 factorial. You find that a sub 3 is equal to 4. Substitute 4 in for n. Simplify 4 plus 1. Factor 5 factorial into 5 times 4 factorial. Simplify 5 times 4 factorial divided by 4 factorial. You find that a sub 4 is equal to 5. Substitute 5 in for n. Simplify 5 plus 1. Factor 6 factorial into 6 times 5 factorial. Simplify 6 times 5 factorial divided by 5 factorial. You find that a sub 5 is equal to 6. The first 5 terms of the sequence are 2, 3, 4, 5, and 6. Simplify the expression 5 factorial divided by 4 factorial. Factor 5 factorial into 4 factorial times 5. Simplify 4 factorial times 5 divided by 4 factorial. 5 factorial divided by 4 factorial is equal to 5.
Simplify the expression 25 factorial divided by 20 factorial times 5 factorial. To simplify this expression, you can first factor 25 factorial as 20 factorial times 21 times 22 times 23 times 24 times 25. Now, notice that there is a common factor of 20 factorial in both the numerator and the denominator, so you can divide out this common factor, leaving you with 21 times 22 times 23 times 24 times 25, all divided by 5 factorial. Next, you can factor 5 factorial as 1 times 2 times 3 times 4 times 5. Now, in your numerator, you can factor 21 as 3 times 7, you can factor 22 as 2 times 11, you can factor 24 as 4 times 6, and you can factor 25 as 5 times 5. Now, notice that there is a common factor of 2, 3, 4, and 5 in both the numerator and the denominator. So you can divide out these common factors, leaving you with 7 times 11 times 23 times 6 times 5, all divided by 1. When you simplify, 7 times 11 times 23 times 6 times 5, all divided by 1, gives you 53,130. Therefore, the expression 25 factorial divided by 20 factorial times 5 factorial simplifies to 53,130.
Simplify the expression n factorial divided by n plus 1 factorial. Factor n plus 1 factorial into n factorial times n plus 1. Simplify n factorial divided by n factorial times n plus 1. N factorial divided by n plus 1 factorial is equal to 1 divided by n plus 1. Simplify the expression n plus 1 factorial divided by n minus 1 factorial. Factor n plus 1 factorial into n minus 1 factorial times n plus 1. Simplify n minus 1 factorial times n plus 1 divided by n minus 1 factorial. N plus 1 factorial divided by n minus 1 factorial is equal to n times the quantity n plus 1. Match the sequence with the graph of its first 10 terms. 6 divided by n plus 1. Substitute 1 in for n. Simplify 1 plus 1. Simplify 6 divided by 2. You find that a1 equals 3. That narrows the graphs down to a, b, or d. Substitute 2 in for n. Simplify 2 plus 1. Simplify 6 divided by 3. You find that a2 is equal to 2, so that narrows it down to b. The graph of the first 10 terms of 6 divided by n plus 1 is graph B. Match the sequence with the graph of its first 10 terms. A sub n is equal to 6/10 to the n minus 1. Substitute 1 in for n. Simplify 1 minus 1. Simplify 6/10 to the 0. You find that a1 is equal to 1. That narrows the graphs down to graph C. The graph of a sub n is equal to 6/10 to the n minus 1 is graph C. Write an expression for the nth term of the sequence. Assume that n begins with 1. 1, 3, 5, 7, 9. From this set of numbers, you can see a pattern. The apparent pattern is a sub n is equal to 2n minus 1. Write an expression for the nth term of the sequence. Assume that n begins with 1. 0, 3, 8, 15, 24. From the sequence you can find a pattern. The apparent pattern is a sub n is equal to n squared minus 1.
Write an expression for the nth term of the sequence. Assume that n begins with 1. Negative 1/5, 1/25, negative 1 125th, 1 625th, negative 1 3125th. To write an expression for the nth term of this sequence, first notice that the terms of the sequence are increasing powers of negative 1/5. So the apparent pattern is negative 1/5 to the nth power. Now, following this pattern, when n is odd, negative 1/5 to the nth power will be negative. When n is even, negative 1/5 to the nth power will be positive. This produces the alternating negative and positive terms that appear in the sequence. Therefore, the expression for the nth term of the sequence is a sub n equals negative 1/5 to the nth power.
Find s sub 1, s sub 2, and s sub 6 for a sub n is equal to 2n plus 5. For s sub 1, substitute 1 in for n. Simplify 2 times 1. Simplify 2 plus 5. You find that s sub 1 is equal to 7. For s sub 2, beginning with n equals 1, substitute the number into 2n plus 5. Add the next consecutive substitution until n equals 2. Simplify 2 times 1 and 2 times 2. Simplify 2 plus 5 plus 4 plus 5. You find that s sub 2 is equal to 16. For s sub 6, beginning with n equals 1, substitute the number into 2n plus 5. Add the next consecutive substitution until n equals 6. Simplify 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 2 times 6. Simplify 2 plus 5 plus 4 plus 5 plus 6 plus 5 plus 8 plus 5 plus 10 plus 5 plus 12 plus 5. You find that s sub 6 is equal to 72.
Find s sub 2, s sub 3, and s sub 9 for a sub n equals 1 divided by n. To find s sub 2, s sub 3, and s sub 9, you first need to find the first 9 terms of the sequence, beginning with n equals 1, by substituting the values 1 through 9 for n into the expression 1 divided by n. When you simplify, you get the following values. Now, s sub 2 is equal to a sub 1 plus a sub 2. So you can substitute in the values for a sub 1 and a sub 2. When you simplify, 1 plus 1/2 gives you 3/2. Therefore, s sub 2 equals 3/2. Next, s sub 3 is equal to a sub 1 plus a sub 2 plus a sub 3. So you can substitute in the values for a sub 1, a sub 2, and a sub 3. Now, to simplify, you first need to rewrite each fraction with a common denominator of 6. Next, in your numerator, 6 plus 3 plus 2 gives you 11. Therefore, s sub 3 equals 11/6. Finally, s sub 9 is equal to the sum of the first 9 terms of the sequence. So you can substitute in the values for a sub 1 through a sub 9. Now, to simplify, you first need to rewrite each fraction with a common denominator of 2,520. Next, when you add the terms in your numerator together, you get 7,129. Therefore, s sub 9 equals 7,129 divided by 2,520.
Find the partial sum, the sum from k equals 1 to k equals 5 of 6. Add 6 5 times. Simplify 6 plus 6 plus 6 plus 6 plus 6. You find that the sum from k equals 1 to 5 of 6 is 30. Find the partial sum, the sum from I equals 0 to I equals 6 of 2i plus 5. Beginning with I equals 0, substitute the number into 2i plus 5. Add the next consecutive substitution until I equals 6. Simplify 2 times 0, 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 2 times 6. Simplify 0 plus 5 plus 2 plus 5 plus 4 plus 5 plus 6 plus 5 plus 8 plus 5 plus 10 plus 5 plus 12 plus 5. We find that the sum from I equals 0 to I equals 6 of 2I plus 5 is 77. Find the partial sum. The sum from j equals 0 to j equals 3 of 1 divided by j squared plus 1. Beginning with j equals 0, substitute the number into 1 divided by j squared plus 1. Add the next consecutive substitution until j equals 3. Simplify 0 squared, 1 squared, 2 squared, and 3 squared. Simplify 0 plus 1, 1 plus 1, 4 plus 1, and 9 plus 1. Multiply the fractions by the least common denominator. Simplify 10 plus 5 plus 2 plus 1. Simplify 18 divided by 10. The sum from j equals 0 to 3 of 1 divided by j squared plus 1 is equal to 9/5. Find the partial sum. The sum from n equals 0 to n equals 5 of negative 1/3 to the n. Beginning with n equals 0, substitute the number into negative 1/3 to the n. Add the next consecutive substitution until n equals 5. Simplify negative 1/3 to the 0, negative 1/3 to the first, negative 1/3 squared, negative 1/3 cubed, negative 1/3 to the fourth, and negative 1/3 to the fifth. Multiply the fractions by the least common denominator. Simplify 243 minus 81 plus 27 minus 9 plus 3 minus 1. You find that the sum from n equals 0 to n equals 5 of negative 1/3 to the n is 182 divided by 243. Write the sum in sigma notation. Begin with k is equal to 1. 1 plus 2 plus 3 plus 4 plus 5. The apparent pattern is k. The sum in sigma notation is the sum from k equals 1 to k equals 5 of k. Write the sum in sigma notation. Begin with k is equal to 1. 1/2 plus 2/3 plus 3/4 plus 4/5 plus 5/6 plus 11/12. The pattern appears to be k divided by k plus 1. The sum in sigma notation is the sum from k equals 1 to k equals 11 of k divided by k plus 1. Find the common difference of the arithmetic sequence 2, 5, 8, 11. From 8 to 11, 8 to 5, and 5 to 2, you have to subtract 3, so the common difference is 3. Find the common difference of the arithmetic sequence 100, 94, 88, 82. To get from 82 to 88, 88 to 94, and 94 to 100, you need to add 6. So the common difference is negative 6. Find the common difference of the arithmetic sequence 4, 9 halves, 5, 11 halves, 6. To get from 6 to 11 halves to 5, 5 to 9 halves, and 9 halves to 4, you have to subtract 1 half. The common difference is 1 half. Find the common difference of the arithmetic sequence in the given nth term. A sub n is equal to 4n plus 5. Substitute 1 in for n. Simplify 4 times 1. Simplify 4 plus 5. You find that a sub 1 is equal to 9. Substitute 2 in for n. Simplify 4 times 2. Simplify 8 plus 5. You find that a sub 2 is equal to 13. Substitute 3 in for n. Simplify 4 times 3. Simplify 12 plus 5. You find that a sub 3 is equal to 17. Substitute 4 in for n. Simplify 4 times 4. Simplify 16 plus 5. You find that a sub 4 is equal to 21. To get from 21 to 17, 17 to 13, and 13 to 9, you need to subtract 4. The common difference is 4. Find the common difference of the arithmetic sequence with the given nth term. A sub n is equal to 8 minus 3n. Substitute 1 in for n. Simplify 3 times 1. Simplify 8 minus 3. You find that a sub 1 is equal to 5. Substitute 2 in for n. Simplify negative 3 times 2. Simplify 8 minus 6. You find that a2 is equal to 2. Substitute 3 in for n. Simplify negative 3 times 3. Simplify 8 minus 9. You find that a sub 3 is equal to negative 1. Substitute 4 in for n. Simplify negative 3 times 4. Simplify 8 minus 12. You find that a sub 4 is equal to negative 4. To get from negative 4 to negative 1 to 2, and from 2 to 5, you need to add 3. So the common difference is negative 3. Find the common difference of the arithmetic sequence with the given nth term. A sub n is equal to 1/2 times the quantity n plus 1. Substitute 1 in for n. Simplify 1 plus 1. Simplify 1/2 times 2. You find that a sub 1 is equal to 1. Substitute 2 in for n. Simplify 2 plus 1. Simplify 1/2 times 3. You find that a sub 2 is equal to 3/2. Substitute 3 in for n. Simplify 3 plus 1. Simplify 1/2 times 4. You find that a sub 3 is equal to 2. Substitute 4 in for n. Simplify 4 plus 1. Simplify 5 times 1/2. You find that a sub 4 is equal to 5/2. To get from 5/2 to 2, 2 to 3/2, and 3/2 to 1, you need to subtract 1/2. The common difference is 1/2.
Find a formula for the nth term of the arithmetic sequence. A sub 1 equals 4 and d equals 3. Use the formula for the nth term of the arithmetic sequence. A sub n equals a sub 1 plus the quantity n minus 1 times d. Substitute 4 in for a sub 1 and 3 in for d. Simplify the quantity n minus 1 times 3. Simplify 4 minus 3. You find the formula for the nth term of the arithmetic sequence to be a sub n equals 3n plus 1. Find a formula for the nth term of the arithmetic sequence. A sub 1 equals 1/2 and d equals 3/2. Use the formula for the nth term of an arithmetic sequence. A sub n equals a sub 1 plus the quantity n minus 1 times d. Substitute 1/2 in for a sub 1 and 3/2 in for d. Simplify the quantity n minus 1 times 3/2. Simplify 1/2 minus 3/2. You find that the formula for the nth term of this arithmetic sequence is a sub n equals 3/2 n minus 1. Find the formula for the nth term of the arithmetic sequence. A sub 1 equals 100 and d equals -5. Use the formula for the nth term of an arithmetic sequence. A sub n equals a sub 1 plus the quantity n minus 1 times d. Substitute 100 in for a sub 1 and -5 in for d. Simplify the quantity n minus 1 times -5. Simplify 100 plus 5. You find that the formula for the nth term of this arithmetic sequence is a sub n equals -5n plus 105. Find a formula for the nth term of the arithmetic sequence. A sub 3 equals 6 and d equals 3/2. To find a formula for the nth term of this arithmetic sequence, you first need to find the value of a sub 1. To do this, use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. In this problem, you are given the values of a sub 3 and d, so you can substitute a sub 3 in for a sub n, 3 in for n, and 3/2 in for d. Because a sub 3 equals 6, substitute 6 in for a sub 3. Simplify 3 minus 1. Simplify 2 times 3/2. Subtract 3 from both sides. You find that a sub 1 equals 3. Now that you know the value for a sub 1, you can substitute this value and the value for d into the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. Simplify the quantity n minus 1 times 3/2. Simplify 3 minus 3/2. You find that the formula for the nth term of this arithmetic sequence is a sub n equals 3/2 n plus 3/2. Find a formula for the nth term of the arithmetic sequence. A sub 1 equals 5 and a sub 5 equals 15. To find a formula for the nth term of this arithmetic sequence, you first need to find the value of d. To do this, use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. You are given that the value of a sub 1 is 5 and that the value of a sub 5 is 15. So you can substitute a sub 5 in for a sub n, 5 in for a sub 1, and 5 in for n. Because a sub 5 equals 15, substitute 15 in for a sub 5. Simplify 5 minus 1. Subtract 5 from both sides. Divide both sides by 4. Reduce the fraction. You find that d equals 5/2. Now that you know the value of d, you can substitute this value and the value for a sub 1 into the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. Simplify the quantity n minus 1 times 5 halves. Simplify 5 minus 5 halves. You find that the formula for the nth term of this arithmetic sequence is a sub n equals 5 halves n plus 5 halves.
The first two terms of an arithmetic sequence are given. Find the missing term. A sub 1 is equal to 5, a sub 2 is equal to 11, a sub 10 is equal to blank. Subtract a sub 1 from a sub 2. Simplify 11 minus 5. You find that a sub 2 minus a sub 1 is equal to 6, which is equal to d. Use a sub n is equal to a sub 1 plus n minus 1 times d. Substitute 10 in for n, 5 in for a sub 1, and 6 in for d. Simplify 10 minus 1. Simplify 9 times 6. Simplify 5 plus 54. You find that a sub 10 is equal to 59. Write the first 5 terms of the arithmetic sequence defined recursively. A sub 1 is equal to 14. A sub k plus 1 is equal to a sub k plus 6. A sub 1 is equal to 14. A sub 2 is equal to 14 plus 6. Simplify 14 plus 6. A sub 2 is equal to 20. A sub 3 is equal to 20 plus 6. Simplify 20 plus 6. A sub 3 is equal to 26. A sub 4 is equal to 26 plus 6. Simplify 26 plus 6. A sub 4 is equal to 32. A sub 5 is equal to 32 plus 6. Simplify 32 plus 6. A sub 5 is equal to 38. The first 5 terms of the arithmetic sequence are 14, 20, 26, 32, and 38. Write the first 5 terms of the arithmetic sequence defined recursively. A sub 1 equals 23. A sub k plus 1 is equal to a sub k minus 5. A sub 1 equals 23. A sub 2 equals 23 minus 5. Simplify 23 minus 5. A sub 2 equals 18. A sub 3 equals 18 minus 5. Simplify 18 minus 5. A sub 3 equals 13. A sub 4 equals 13 minus 5. Simplify 13 minus 5. A sub 4 equals 8. A sub 5 equals 8 minus 5. Simplify 8 minus 5. A sub 5 equals 3. The first 5 terms of the arithmetic sequence are 23, 18, 13, 8, and 3. Find a sub 1, and b, a sub 5. A sub 4 is equal to 23, and d is equal to 6. Part A. Use a sub n is equal to a sub 1 plus n minus 1 quantity times d. Substitute 4 in for n. Substitute 23 in for a sub 4 and 6 in for d. Simplify 4 minus 1. Simplify 3 times 6. Subtract 18 from both sides. You find that a sub 1 is equal to 5. Part B. Substitute 5 in for n. Substitute 5 in for A1 and 6 in for D. Simplify 5 minus 1. Simplify 4 times 6. Simplify 5 plus 24. You find that a sub 5 is equal to 29. Find the partial sum. The sum from k equals 1 to k equals 20 of k. Use the nth partial sum formula. Substitute 20 in for n. Substitute 1 in for k and substitute it in for a sub 1, and substitute 20 in for k and substitute it in for a sub 20. Simplify 1 plus 20. Simplify 20 divided by 2. Simplify 10 times 21. You find the sum from k equals 1 to k equals 20 of k is equal to 210. Find the partial sum. The sum from k equals 1 to k equals 50 of k plus 3. Use the nth partial sum formula. Substitute 50 in for n. Substitute 1 into k plus 3 and substitute it into a sub 1, and substitute 50 into k plus 3 and substitute it in for a sub 50. Simplify 1 plus 3 plus 50 plus 3. Simplify 50 divided by 2. Simplify 25 times 57. You find that the sum from k equals 1 to k equals 50 of k plus 3 is equal to 1,425. Find the partial sum. The sum from k equals 1 to k equals 10 of 5k minus 2. Use the nth partial sum formula. Substitute 10 in for n. Substitute 1 in for k and substitute it into a sub 1. Substitute 10 in for k and substitute it into a sub 10. Simplify 5 minus 2 plus 50 minus 2. Simplify 10 divided by 2. Simplify 5 times 51. We find that the sum from k equals 1 to k equals 10 of 5k minus 2 is equal to 255. Find the partial sum. The sum from n equals 1 to n equals 500 of n divided by 2. Use the nth partial sum formula. Substitute 500 in for n. Substitute 1 in for n and substitute it into a sub 1. Substitute 500 in for n and substitute it into a sub 500. Simplify 1/2 plus 500 halves. Simplify 500 divided by 2. Simplify 250 times 501 divided by 2. You find that the sum from n equals 1 to n equals 500 of n divided by 2 is 62,625. Find the partial sum. The sum from n equals 1 to n equals 30 of 1/3 n minus 4. Use the nth partial sum formula. Substitute 30 in for n. Substitute 1 in for n in 1/3 n minus 4 and substitute it into a sub 1. Substitute 30 in for n in 1/3 n minus 4 and substitute it into a sub 30. Simplify 1/3 minus 4 plus 10 minus 4. Simplify 30 divided by 2. Simplify 15 times 7 divided by 3. You find that the sum from n equals 1 to n equals 30 of 1/3 n minus 4 is 35. Find the nth partial sum of the arithmetic sequence. 5, 12, 19, 26, 33. N is equal to 12. To get from 33 to 26, 26 to 19, 19 to 12, and 12 to 5, we must subtract 7. So D is equal to 7. Use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times D. Substitute 5 in for a sub 1 and 7 in for D. Simplify 7 times the quantity n minus 1. Simplify 5 minus 7. You find that a sub n is equal to 7n minus 2. Substitute 12 in for n. Simplify 7 times 12. Simplify 84 minus 2. You find that a sub 12 is equal to 82. Use the nth partial sum formula. Substitute 12 in for n. Substitute 5 in for a sub 1 and 82 in for a sub 12. Simplify 5 plus 82. Simplify 12 divided by 2. Simplify 6 times 87. You find that the 12th partial sum of the arithmetic sequence 5, 12, 19, 26, 33 is 522. Find the nth partial sum of the arithmetic sequence negative 50, negative 38, negative 26, negative 14, negative 2. N is equal to 50. To get from negative 2 to negative 14, negative 14 to negative 26, from negative 26 to negative 38, and from negative 38 to negative 50, you have to subtract 12. So you find that D is 12. Use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times D. Substitute negative 50 for a sub 1 and 12 for D. Simplify 12 times the quantity n minus 1. Simplify negative 50 minus 12. You find that a sub n is equal to 12n minus 62. Substitute 50 for n. Simplify 12 times 50. Simplify 600 minus 62. You find that a sub 50 is equal to 538. Use the nth partial sum formula. Substitute 50 in for n, negative 50 in for a sub 1, and 538 in for a sub n. Simplify negative 50 plus 538. Simplify 50 divided by 2. Simplify 25 times 488. You find that the 50th partial sum of the arithmetic sequence negative 50, negative 38, negative 26, negative 14, negative 2 is 12,200. Find the nth partial sum of the arithmetic sequence 1, 4 and 5 tenths, 8, 11 and 5 tenths, 15. N is equal to 12. To get from 15 to 11 and 5 tenths, 11 and 5 tenths to 8, 8 to 4 and 5 tenths, and 4 and 5 tenths to 1, you have to subtract 3 and 5 tenths. You find that D is equal to 3 and 5 tenths. Use the formula a sub n is equal to a sub 1 plus n minus 1 quantity times D. Substitute 1 in for a sub 1 and 3 and 5 tenths in for D. Simplify n minus 1 times 3 and 5 tenths. Simplify 1 minus 3 and 5 tenths. You find that a sub n is equal to 3 and 5 tenths n minus 2 and 5 tenths. Substitute 12 in for n. Simplify 3 and 5 tenths times 12. Simplify 42 minus 2 and 5 tenths. You find that a sub 12 is equal to 39 and 5 tenths. Use the nth partial sum formula. Substitute 12 in for n. Substitute 1 in for a sub 1 and 39 5/10 in for a sub 12. Simplify 1 plus 39 5/10. Simplify 12 divided by 2. Simplify 6 times 40 5/10. You find that the 12th partial sum of the arithmetic sequence 1, 4 5/10, 8, 11 5/10, 15 is 243. Find the nth partial sum of the arithmetic sequence. A sub 1 is equal to 5/10, a sub 4 is equal to 1 7/10, n is equal to 10. Use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Substitute 4 in for n. Substitute 5/10 in for a sub 1 and 1 7/10 in for a sub 4. Simplify 4 minus 1. Subtract 5/10 from both sides. Divide both sides by 3. You find that d is equal to 4/10. Substitute d into a sub n is equal to 5/10 plus the quantity n minus 1 times d. Simplify n minus 1 times 4/10. Simplify 5/10 minus 4/10. You find that a sub n is equal to 4/10 n plus 1/10. Substitute 10 in for n. Simplify 4/10 times n. Simplify 4 plus 1/10. You find that a sub 10 is equal to 4 1/10. Use the nth partial sum formula. Substitute 10 in for n, 5/10 in for a sub 1, and 4 1/10 in for a sub n. Simplify 5/10 plus 4 1/10. Simplify 10 divided by 2. Simplify 5 times 4 6/10. The 10th partial sum of the arithmetic sequence a sub 1 is equal to 5/10, a sub 4 is equal to 1 7/10 is 23. Find the sum of the first 75 positive integers. Let 75 equal n. The first positive integer is 1. Set that equal to a sub 1. The 75th positive integer is 75, so set that equal to a sub 75. Use the nth partial sum formula. Substitute 75 in for n, 1 in for a sub 1, and 75 in for a sub n. Simplify 1 plus 75. Simplify 75 divided by 2 times 76. The sum of the first 75 positive integers is 2,850. In your new job as an actuary, your starting salary will be $54,000 with an increase of $3,000 at the end of each of the first 5 years. How much will you be paid through the end of your first 6 years of employment with the company? Use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Let $54,000 equal a1 and $3,000 equal d, and substitute them into the equation. Simplify 3,000 times n minus 1. Simplify 54,000 minus 3,000. You find that a sub n is equal to 3,000n plus 51,000. Substitute 6 in for n. Simplify 3,000 times 6. Simplify 18,000 plus 51,000. You find that a sub 6 is equal to 69,000. Use the nth partial sum formula. Substitute 6 in for n, 54,000 in for a sub 1, and 69,000 in for a sub n. Simplify 54,000 plus 69,000. Simplify 6 divided by 2. Simplify 3 times 123,000. You will be paid $369,000 through the end of your first 6 years of employment. In the first 2 trips baling hay around a large field, see figure, a farmer obtains 93 bales and 89 bales respectively. The farmer estimates that the number will continue to decrease in a linear pattern. Estimate the total number of bales obtained after completing the 6 remaining trips around the field. Let 93 equal a sub 1 and 89 equal a sub 2. Subtract a sub 1 from a sub 2. Simplify 89 minus 93. A sub 2 minus a sub 1 is equal to negative 4, which is equal to d. Use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Substitute 93 in for a sub 1 and negative 4 in for d. Simplify negative 4 times n minus 1. Simplify 93 plus 4. You find that a sub n is equal to negative 4 plus 97. Substitute 8 in for n. Simplify negative 4 times 8. Simplify negative 32 plus 97. You find that a sub 8 is equal to 65. Use the nth partial sum formula. Substitute 8 in for n, 93 in for a sub 1, and 65 in for a sub n. Simplify 93 plus 65. Simplify 8 divided by 2. Simplify 4 times 158. The farmer will obtain 632 bales of hay from the field.